I think I might have crashed it. Oh no, we got it. Okay, so we got 0.1 for n. How do we find m?
Basically like a minus n. Well, no, because all of a is 0.3 and we have minus n.
Very good, okay. So m is the probability of a minus the 0.1. So good, m is 0.2. Alright, so we got that, 0.2. Now what?
Now, the both of them, a and b is 0.6, so you just gotta just do it. So
A plus b minus the intersection.
Yeah, minus b. Yeah, exactly.
Okay.
Then you get 0.3 equal to that.
Alright. Yeah, we'll get 0.3. Think of it this way. 0.6 is m plus n plus p, right? It's this plus this plus this, right? That's the union of everything. So I know m and n add up to 0.3. So that means p has to be 0.6. Okay?
You mean 3?
0.3, yeah, I can subtract. 0.3.
Just checking. He's testing us, guys.
Yes, I was testing you. So then, question, what is Q then?
Well, this is all of them minus
Just
1.
1 minus.
All right, good. 1 minus all of them. That's where we go back up to here. All 4 of those have to add up to 1. These all add up to 0.6.
Look, 0.4.
So that's right. Q is 0.4.
And b not is 0.6.
All right, so B prime, what is that one?
0.6.
0.6. It's 1 minus probability of B. And probability of B is 0.3 plus 0.1. So good. That's 0.6. Okay? Yes.
Could I have done finding P with the formula for A union B? Like, I got the same answer.
Yeah, you could have. Because you knew the intersection, you knew A, and you knew the union.
Yeah, I just set the formula equal to 0.6 because you knew A union B, and then I had 0.3 plus B minus 0.1.
Yeah.
Probability of A plus probability of B minus A or B, or A and B.
That's right. All right. So yeah, you've got this. You were told this was 0.6. Probability of A, you were already told was a 0.3. You were trying to find the probability of B minus the intersection you were told was 0.1. So that would have told you what all of the probability of B was, which was 0.4. And then, okay, well, 0.1 is that much, so 0.3 was that much. Yeah, as long as you use some kind of a valid method of doing it, they don't care, you know, how you end up there. Okay, unless it says hence, then you have to use what you just figured out on the previous step.
So we get follow through, right?
You can get follow through, yeah. So if you messed up I for some reason here, you like put the 0.3 down or something. If you did everything else in relation to that, then yeah, you could get follow through marks. Or if you messed up P, but then you used that correctly in doing part B when you were doing 1 minus the probability of B. So, all right, any other questions? Okay, now, I want to point out one thing as a reminder. There's some stuff we learned to do with the normal distribution. Okay, we're not doing this problem. 5th period did this one, so you can look at that video for the explanation. But we used the functions normal CDF and inverse norm, okay? Normal CDF and inverse norm. You're going to need a calculator for our next problem here. Normal CDF, remember, gives you the probability with a given mean and standard deviation. What's the probability that a randomly selected variable is going to be within a certain range? Okay? So there's your normal CDF, lower bound, upper bound, mean, and standard deviation.
Sometimes you do like,
Okay?
where is that? You do like one thing.
That's under distributions. It's above, it's second bars. Okay. And then inverse norm is kind of the opposite. Here's the probability that we are less than a particular score, okay? Given the mean and standard deviation, this tells us what that score is.
But there were some where you had to do like 1 minus normal CDF.
That's if you wanted above. If you wanted, what's the probability that it's like greater than something?
Then you do 1 minus normal CDF for the 1.
Yeah, well, I mean, normal CDF, you get a lower bound, upper bound, so you actually don't have to do it with that. But with this,
1 minus inverse.
if you were told that the area above a certain value was something, you'd have to do 1 minus that and plug that in here, because this is always an area below. All right? So, I've given you guys more help than I did 5th period. Yeah.
How many, like, what is, do you get, if you get half of them correct on the exam, say, what does that translate to in your score?
A 50% on the exam is approximately a 4.
Okay.
Awesome.
So, all right, so here we go. This one is 13 marks. It says a box contains a large number of biscuits, or cookies if you're in America, biscuits if you're in Britain. The weights of the biscuits are normally distributed with a mean of 7 grams and a standard deviation of 0.5 grams. So we would say X is distributed normally 7.5 squared, okay? Because remember, it's always mean and then the variance goes in here. And they often write it as the standard deviation squared, just to remind us that that's the variance. Okay? So here's the problem, multiple parts. One biscuit is chosen at random from the box. Find the probability that this biscuit weighs less than 8 grams or weighs between 6 and 8 grams. Then B, 5% of the biscuits in the box weigh less than D grams. Copy and complete the normal distribution diagram to represent the information indicating D and shading the appropriate region. Then find the value of D. And then it says here, the weights of biscuits in another box are normally distributed with mean, mu, and standard deviation, 0.5 grams. It is known that 20% of the biscuits in the second box weigh less than 5 grams. Find the value of mu. Okay? So, I'm going to give you 13 minutes to give this one a shot. Do as much as you can with it. Alright? Go ahead. Oh. Come on, focus and use this time. Don't blow this up, alright? I want anyone to crash and burn 4 weeks from, or 5 weeks from tomorrow.
What about 5 weeks from tomorrow?
Yep.
We have 4 weeks.
Okay. Well, you do. I don't.
Don't worry about it, just focus, come on. Just don't talk.
Mr. Nixon, would you be able to tell me like what the C and Z example of the BP is for?
C is cumulative, P is just probability.
Okay.
P was for graphing, we're not gonna use that one at all.
Oh,
On the norm. The only PDF we used was the binomial PDF and the binomial.
so you want three significant figures, so you would want one like that, you want one like
Well, round it.
106.
About 8 more minutes.
How many more minutes?
8. How are we doing? Are you guys about done? This one's fast. All right. Go ahead. If the bell rings and you must go, you can. I'll explain the whole thing here, so it's at least recorded. Okay, first of all, one biscuit's chosen, find the probability that it's less than 8 grams. You're going to use your normal CDF. And you're going to go, if I want less than 8 grams, I need to just plug in a number for the lower bound that's going to be far enough below it that it'll have quite a few standard deviations. So even if I use 0 here, if you want to put in negative 9999, you're welcome to. 0 even will work. So 0, then the upper bound is 8, and then the mean is 7, standard deviation is 0.5. If you are going, go quietly, please. Have a good day. You do that, and whatever you get on your calculator, what you'll get. 0.97?
0.977.
Okay? So 0.977, okay? What? You could do 97.7%. Yeah, that's fine. If it weighs between 6 and 8 grams, again, normal CDF. And you're just going to put 6 and then 8, 7, and 0.5. And that ends up giving you 0.954. What?
How can 95% of it be between 6 and 8 if 97?
Because that's what number mean.
Well, because think about the mean and what you know about your variance or your standard deviation. The mean, and this will help with part B anyways, the mean's here at 7, and then every 0.5, you know, from 7.5, 6.5 to 7.5 is approximately 68%. So then from 6 to 8, that's 2 standard deviations, that's approximately 95%. And you can see that there. Okay? Now, this is, if that's 95%, that means that below this and above this are each about 2.5%. Okay? Approximately 2.5%. So that makes sense. 95 plus 2.5 is about 97.5, 0.977. Okay.
I think it's 3
You should be accurate to 3 decimal places. Now, if this, I guess it's theoretically because they gave you ones that are right on the standard deviations, it's possible they could give you this on a non-calculator part. Okay? Now, they couldn't expect you to get part B and find D, the value of D here without a calculator, so that's why I'm pretty confident that this is on a on a calculator part. Okay, so but theoretically they could give you one similar to this on a non-calculator part. They would just make sure it's all on the standard deviations. Now, to illustrate this, they said 5%. Well, the mean is what percent? 50%. Okay, everything up to the mean is 50%. 5% way less than D. So that means I'm going to put D somewhere here, and you should label D, and then it says indicate D and shade the appropriate region. So we're just going to color in this. And that'll be like the easiest 2 marks on the exam. Okay? Then you can find the value of D by using inverse norm. And remember, that takes the area below. So the area below is 5%, so 0.05. And then the mean and the standard deviation again. Okay? And what do we get when we do that? Does anyone have that?
Yes, 6.178.
Okay? All right. So this value of D is 6.178.
Question.
Mhm.
I completely estimated that D was 6, and I wrote down like the drawing, and I wrote down like whatever, assume D was 6 to continue, like assuming it was wasn't even a problem. Would I still get any marks for that, or because it says find D?
Not for part 2. The drawing was part 1, so you get those marks. That'd be 2 marks. This was probably 3 marks. So you probably would not get any of those for part 2. But if you used that, did you use that at all?
No, but I thought it
Okay.
would be used in C, so I just like.
Okay, if you used it for C, then you could get follow-through marks. But mhm.
If we decide, I just put the answer and I write the normal CDA and what I would I get partial mark?
I'd have to look at the exact mark scheme on these. Because it's a calculator part, they are a little bit more free with giving you points for just writing down the answer. I would, just to be safe, write down what you're putting into your calculator.
So maybe I wrote down points for this one.
so-
I just put equals 6.
Well, if you just put 6, I mean that you didn't, it's not rounded properly, so you wouldn't. But like up here, if you just wrote down 0.977,
Okay.
then you might get full marks. I just wouldn't take the risk because it's kind of hit or miss as far as whether they give you marks or not for that. All right, now here it says the weights of biscuits in another box are normally distributed with a mean mu and standard deviation of 0.5. It's known that 20% of the biscuits in this second box weigh less than 5 grams. Okay? So find the value of mu. Now, what you want to do here is you need to figure out what z-score, since we don't know the mean. Anytime you don't know the mean or standard deviation, you only know one or the other, think z-scores. Because remember, z is x minus mu over the standard deviation. Okay? Now, we know that the score that we're dealing with is 5. We don't know the mean, but we know this is 0.5. So, but we can figure out z. And we do that by using inverse norm. Okay? The z is inverse norm. And the area is going to be the percentage, so 0.2. And then the standard normal to find z, remember, always has a mean of 0 and standard deviation of 1.
Oh.
Okay? So if we do that, we can do inverse norm.
Where the point 2 come from?
It's given.
That's the area, the 20%. Okay? So inverse norm of 0.2, comma 0, comma 1. And here we get z equal to a negative 0.84162. Okay? So that's the z. So I know 5 minus the mean over 0.5 has to equal a negative 0.842. I'll write that, but I'm going to leave the full value in my calculator so I can.
You can do the CF.
Well, now
It's just.
it's just algebra. Multiply that by a half.
Oh, we're always trying to find you.
Yeah, multiply by a half.
So negative 0.4208 equals, sorry, that's a 5, minus mu, subtract 5 and make it positive.
So easy.
Mu is 5.42, that's 2 significant digits.
Oh, I got up to 3 without it.
All right, so 5 point, what'd you do? Just like plug and chug?
Random step. Here's
Nice.
my table.
Would that get points if you did that?
Who's doing it?
Brute force.
It took 10 minutes.
You can use
longer than I
brute force methods, but if you use brute force methods, you need to show at least 3 attempts to get marks for working.
That's beautiful.
So, alrighty. Thanks for staying. We'll see you guys.
One word, please.